Hey friends, how are you? I hope you are absolutely fine. Today I will talk about gradient boosting for regression. You know that regression and classification problems are basically supervised learning. If you bifurcate the two branches of machine learning, one is supervised learning, another one is the unsupervised learning. Under supervised learning, you will have regression and classification, basically where there is a level data. If there is data is not leveled, that's basically unsupervised learning. Under this unsupervised learning, you will have principal component analysis, your clustering, your factor analysis. This couple of areas are covered in the unsupervised learning. So okay, and this gradient boosting algorithm is very well known, and that is very commonly used in industry practices. Okay, so now suppose today we'll talk about the gradient boosting for regression. Okay, fine. So suppose we have example dataset. Suppose you do have a dataset that is have two axes. One is x1 and x2, and that is basically you have to predict if these two features are given. Suppose if the area is a urban area, suppose, and floor is on the first floor, then what will be the price per square feet? That is your y variable. Okay, so this is the urban area and this is first floor, and this per square feet value is, that is nothing but 2.5k INR. Okay, suppose all these are INRs. Okay. And this is your in this particular thing is situated in the rural area. This is your first floor, and this is price per square feet, that is 1,100 INR per square feet. Okay, so according you can see that urban area 12th floor, that is 3.2k INR, and urban area 9th floor, that is 3.0k INR. Okay. So we have to predict. Okay, so based on this. So now just I will talk about the basic intuition over here. So how to predict this? Just we have the whole entire construct in front of you. If you follow the things, then you can understand very easily over here. Okay, so if you know about the regression tree, regression and classification trees, then it will be very easy to understand for you. Okay, so in the first step, what we will follow, so we'll create a base model. Okay, so you do have a base model, that is your B. Fine. So what will be the base model? Base model output is nothing but this, the average of all these values. How these average values are coming in the base model? Suppose you are, for your first prediction, that is your y0 hat. Okay, is your zeroth prediction. Okay, that's basically the base model. Okay, so how to calculate this y0? That is your MS. That will come from the MSE criteria. You have already known that for regression purpose, the loss function used over here, that is the MSE, mean square error. Okay. So what will be the mean square error over here? Suppose 2.5. You are predicting for each and every one the same. Okay. So 2.5 minus y0 hat whole square plus this one. You can see it from here. 2.5 minus y0 square plus 1.1 minus y0 square, like this, and half into how many variables, how many rows you are training over here, that is nothing but how many outputs do you have over here, that is 4 outputs, 1 2 3 4. Okay, just you are taking these 4 samples for your training purpose, so it will be 2 into 4, and this is your MSE. I think there is no such confusion behind this. Okay, so for an optimum point, suppose you have to minimize the loss in this base model. So what will happen? So that is dMSE divided by dy0 equals to 0. You can find, then just you do the derivative of this MSE. respect to y0, just you will get that 2 into this much, 2 into this much, like this it will be 0 like this, and you will get all these will be cancelled, and just do it of your own, just and comment below you are getting this whole entire construct or not. Okay, fine. You can for your own purpose you can use your own loss function over there. Okay, so that's for your criteria, you for your purpose you can use your loss function, doesn't matter whatever it is, but output should be meaningful and output should be business beneficial. That's the main criteria. Okay, so commonly for the regression we use the MSE. So this is for the optimum point, this is the value, and what will be the value of y0, that is the average of all these four outputs, correct? Fine. So just I have written over here. So for each and every inputs, what will be my base model output, that is my base model output 2.45, 2.45, 2.45. Now for in this particular training setup, so what will be my first residual? What will be my first residual? That is nothing but 2.5 minus 2.45. That is 0.05, 1.1 minus 2.45 equals to this much. So you can have the first residual setup over here. Okay, so in the first step what we are doing, that is create the base model using the loss function MSE. Using this loss function, just we have created the base model. This is my base model output, correct? This is a y predicted, and after this y predicted, just we are getting the residuals from it. Now what we have to do, just we have to feed a regression tree trained on this. This is the input and this is the output. What will be the output in this training? That is your R1. This particular, sorry, not this one. For this particular R1, just you have to train it over here, correct? So for this and what will be your input? That is nothing but will be the same. These two columns will be the input and this will be the output. And okay, so this will be the input and this will be the output in this regression tree setup. Okay, and if you let us suppose you are getting a tree over here, you got a tree. Suppose this tree is your T1. Okay. So for this tree, for this T1, what you have to do? You have to pass these particular inputs again. Whatever you have trained, just you have to pass the same input over here, correct? So now if you pass the same inputs, because this is a regression tree, as it is a regression tree, then these predictions will differ from this. Okay, so what you have to do, just you have to predict, if you pass the same inputs over here, what will be the predictions? That is your R1 hat column. Okay, so you let us suppose you have trained this one and this one for this particular sample, for this particular sample input. For this particular sample input you have trained this output. Just for this particular sample input you have trained this in this is output. Okay, just you have this output you have trained this particular set u and 9, just you have trained this one. Okay, so now suppose just again you are passing these inputs again. Okay, so what you are getting, that is nothing but this R1. Okay, you are predicting from the tree. Again you are just your input, giving the input the same input features over the same input samples over here. Just you are getting some value over there. Okay, so that is your R1 hat. Okay, so now what will be your Y1 hat? Y1 hat is nothing but Y0 plus eta into R1. Eta is nothing but your learning rate over here. Suppose you are taking for each and every stage, just if you want to, you are not interested about the constant learning rate. Suppose for the first step just you want to take eta 1, in the second step you want to take eta 2, just you can do it. Okay, so how to do it also, just I will give you a hint at the end of the video also. Suppose for this particular setup, for this particular purpose, just take that eta is a constant value. Okay, so for then you have to find this y1 hat, that is y0 plus eta plus r1 hat. Okay, so then what you have to find, just you have to find this r2. Okay, so how to find this r2? That is nothing but this, the output, the same output of the main data set minus minus y1 hat. Then what is your y1 hat? That will come from this particular equation, that is nothing but y0 plus eta r1 hat. Okay, so then you will find this r2. From here just you will find this r2. From here when you will find this r2, what will happen over here? Suppose you are getting all this over here. Okay, so again what you have to do, again you have to train x and r2. Okay, so again what you will find over here, that is nothing but r2 hat. Okay, so what you will get, y2 hat, or y2 hat is nothing but what will be r2 hat, just you will again fit another tree. Suppose you will fit another regression tree, that is say t2. First of all you have you have trained say t1 like this, and for training this r2 just you are fitting another t2 over here. Okay, so from this t2 just you will get some sort of r2 hat also. From there just you will get this y2 hat. How to get this y2 hat? That is nothing but, okay, y2 hat is nothing but y1 hat plus eta r2 hat. So if you iterate this whole entire set for say for nth step, then what will happen? So kth step, what will happen? So yk hat is nothing but yk minus 1 hat plus eta rk hat. So like this. So you will get, what are these hats? R1 hats, R2 hats, that these are the basically tree outputs. What is this R1s? R1s are the basically the residual at each steps, and these particular residuals are taken for the regression tree fitting. Okay, so now what you have got, let us simplify this. In the first step, just you have taken the base model. Say base model is nothing but over here, as you have defined your loss function as the MSE. So what will be the base model output? That is your average of all these outputs. Okay, so plus eta is your learning rate. For your purpose you can define your etas as of your own. Okay, so eta 1 into t1. T1 is what? T1 is your the regression T fitted, you have fitted in the first step. Regression T fitted in the first step using R1 and X1 and X2. That is your T1. Okay, what is your eta 2? That is nothing but regression tree you have fitted using R2 and these inputs. T3 like this. So this particular if you do just now you have got that, say you are iterating up to nth step, then just you will get n number of trees. Okay, so and you will have one base model. So if you have one input, then what you have to do, you have to have the base models. So you are giving an input over here, you will get one base model in output. Say one base model output is over here plus eta 1, and from the base model outputs you are getting say this residual. Okay, yeah, so fine. So from there, this base model input, base you will get one base model output plus T1 plus this first residual tree output into eta 1 plus eta 2 into residual second residual T out tree output, and in this way just you have to form the output. Okay. So if you have a new sample, you have to predict for that. So what you have got, that is nothing but yk hat is equals to yk minus 1 hat plus eta eta k into r k hat, like this. So this is the formula, just you have to iterate. So first of all, you can do, just you can write it down on the pen and paper, and just you have to understand this whole entire scenario. Just this is very easy to understand. Okay? So now just in the middle of the video I have already told that how to choose this eta. This eta is nothing but this learning rate. You can change the learning rate at each and every steps. So for over here, just you have taken that eta will be constant. So this particular eta comes from the Hessian. Okay. So when we'll talk about some little bit more, then how to construct the Hessian from here. Just so many persons over here, you have already known that what is the Hessian. Hessian is nothing but this is your double derivative. If you take you have take single derivative. If you take the two-step derivatives, double derivative, then you can get the Hessians. There is no such rocket science behind it. Okay? So this is a volatile construct, and this is pretty easy to understand. And in the interviews, that is commonly asked. That will be commonly asked to you, and just you can get an overview and how to construct the whole entire scenario. Just you got it, I think so. Okay. So from here, just get the notes and just try to understand and what is the intuition just you have got over here. Just is it okay for you, or is it beneficial for you or not? Then just comment below you have understood the whole entire construct or not. Okay, so just I'll give you one task, that is nothing but if you are using Python, if you are using Python, then Python itself has so many libraries about this gradient boosting. Use this gradient boosting directly, okay, and just in your own intuitive way, just try to construct this model using these trees. Okay, just take this particular say this particular setup for the y0. Say this is your base model plus t1. Try to construct all those trees and define your learning rate over there, and try to make some outputs. Okay, so and try to, for using this gradient boosting regressor and using this whole entire construct, two things are basically same. Okay, two things are basically same. Just you will have some MSE over here, and you will also have some MSE over here. So how much MSEs are differing? Okay, for this particular for these two cases, this of how much MSE is differing for this gradient boosting to this your own constructed gradient boosting algorithm. How much it is differing? Just comment below. It will give pretty much same result, as it is a regression purpose, regression gradient boosting for regression. That will not give you the exact same MSE, but MSEs will be pretty closer. Okay, so I think you enjoyed the whole entire video, and just comment below if I have done some sort of mistake or not. Okay, so for here bye bye. Please subscribe my channel, like this video, and this likes and subscriptions, and press the bell icon. Okay, so these likes and subscriptions will give me the extra motivation for the next video. For today, bye bye. Okay, fine.